Welcome to lesson 8 of the C++ course. In this lesson we're going to talk about inheritance. And in fact in C++ inheritance is not very different from the way you're used to doing it in C# or in Java. If we look at inheritance, of course we have to start with a base class. So let's just use our example we implemented in the previous lessons, the class food. And this food has a few private variables like the string name and the string and the int amount, and it has some public methods. So we have 3 constructors, one with only a food, one with a string name, and one with a string name and an amount. Also we had some getters and we had some setters. Let's say we have some specific fruits like apples, bananas and oranges, which have their own special way of using them. For instance, we could like to cut an apple in pieces, and from an orange we always squeeze them, and a banana we need to peel. Then it's a good thing to use inheritance to make those special objects inherit from the class food. So we have a lot of things in common, but the way they're used is quite different. So in a picture you would see it like this. So we have the food as a base class, and then the apple class, the orange class and the banana class inherit from the food class. And they have a function use, which is defined in the food class and then overridden in the specific children. So the apples, the orange and the bananas, they all have their specific implementation for use. If we have these specific classes, then the string name is of course a little bit over the top, because the food itself, if I'm an apple, I know that I'm an apple, and I don't have to keep this in storage into a string. So in this situation you should get rid of the string name in the food object. Okay, let's see how this works out if we start a Visual Studio application. Okay, let's recap what we've defined in the food header file so far. So we had a string name, an integer amount, we had the static int to keep track of the number of objects, we had several constructors, one with a string and an amount, one with only a string, and one default one with nothing, and we had some public methods, one class method to get the number of food objects, a getter and a setter for the name, and a getter of the setter for the amount. Okay, now we're going to add a class apple, which will inherit from this food class. So let's look at that one. So this class apple inherits, and the inherits is given with the double point public food. That tells the system that this class apple uses fruit as a base class. And now I can, in the public part, add the functions I'd like to override and add new functions. So let's first do the new function, use, and we're going to do our own version of the get name. So string get name. Okay, so these two need to be implemented. And by the way, you can also add extra private variables which are specific for the apple, but let's now just stick to the only extra method we are going to use. So we're going to implement these two methods in the apple CPP file. Okay, for its use, we first have to say it's from the apple class. Okay, from the apple class. And then for the implementation, let's just show something on the screen. So cout, and don't forget the standard, cout, say something like I will be cut in pieces or something like that. Just to make a difference. and line, with standard of course in front of it. Yeah, so that's one implementation. And then we are going to make our own version of the getName. So with class Apple in front of it, we're going to do our own version. And let's just change this one in, not to return of my parameter, but just return my knowledge, because I know I am an apple. So let's tell that I am an apple. Okay, so now we have implemented two functions of this apple, and we could use them in the console application. So we can use it in the console application. So let's make an apple with a name, my apple, and my apple I will just use it the default constructor. And you saw that I didn't make an extra constructor in the apple class, so that means that now he's automatically going to use the default constructor from the food. So that will mean that the amount will be 0 and the variable name, which should get the value unknown. Okay, if I now have this my apple, I can test whatever is in there and say cout my apple getName, and then hopefully I will get the version we just implemented in our apple class. So I should see something like I am an apple, and then after that let's ask for the amount as well. So my apple get amount. Let's put this on a new line so we can still read it. My apple get amount, and that should be 0 because I didn't override the constructor, so the amount would still be the value of the basic constructor. And line. Okay, let's test this. So let's build. Yes, and run. Okay, I am an apple with amount 0. So he uses the method getName from apple, and he uses the amount set with the default constructor from food, and so with the use of the parent. Okay, I can also have different ways of using this one. I could, for instance, say let's create a food, my food, and then use not the default constructor but use the one with the string. So now in the parameter, in the private variable of my food name, there will be an apple inside. Okay, so if I do this, and now I will show cout. Let's just copy this. And then instead of my apple, I will use my food getName and my food getAmount. I would still just see the basic requirements. So I would still just see an apple and I would see amount 0. And so at this moment I can make objects of the class apple as well as of the class food. Let's try to do that. Yeah, so you have an apple with an amount and an apple with an amount. And the first one, I am an apple, is from the object apple from the apple class. And the other one, apple with amount 0, is an object of the fruit class. Okay, so this all works fine. Now let's do something different. Let's work with dynamic memory. So we have a fruit, and this fruit is an FP variable points to fruit. So there's no object attached to it yet. Okay, if I now attach an object to it, I could say FP becomes new, and let's make an apple. So what I'd like to happen is that this FP points to an actual apple. So if I now would do cout and then FP get name, then I would really like to see I'm an apple. And let's see if that works. Okay, that is funny. Then look at the last line. He says unknown. So it doesn't work. How is that possible? Well, simply because the method getName is binded to the FP, to the variable FP, at the moment of the creation of the declaration of this FP. And at that moment, FP thinks I'm going to be a pointer to a fruit. And only later on, the pointer is attached to an actual apple. So to have it use the apple functions, to apple methods, we need to do something called virtual, which will inflict a late binding of the object. So if we don't do anything, then at the moment the variable is declared, we will use the methods attached to this fruit class. That's something we don't know, we don't want. So we only want to have the methods attached at the moment we know what actually object is going to be there. So we want to do that, and we can change it with the help of the keyword virtual. So if we go to fruit header file and we put in front of this getName the keyword virtual, then that means that we are telling this class, please don't bind this method getName at the moment of the declaration, but only at the moment where you really know what kind of object you have. So late binding. Okay, let's see if that works. So we have now this fruit FP, we have a new apple, and now I hope that this getName will use the late binding, so we'll use the implementation of the apple getName. Let's debug. And indeed, it's a miracle. So the last sentence here is I'm an apple. So now indeed, with the use of the keyword virtual, we got a late binding of the method. So when I have this fruit pointer and I attached it to a real apple, then at the moment of creation of the variable, there is no method with a virtual keyword attached yet. But as soon as we really know what we are, so as soon as we did the new apple thing, then we can use the getName of the apple object. Okay, so this is the first part of our classes with inheritance and virtual, and in the next part we'll continue with some more experimenting.